is my pleasure to present the next generation of rover design and space exploration. I give you UBCO's 2020 Canadian Mars Perseverance Rover. Its innovative design and complex structure allows it to accurately and dynamically understand, analyze, and traverse the Martian surface. Welcome to the future.
The Perseverance rover wheel consists of three main parts: the tread, the spokes, and the hub. The hub is connected directly to the suspension only before passing through a motor which powers each of the 6 wheels. Along with the wheel, there is a display plaque consisting entirely of sheet metal parts and a NASA logo on the back.
The suspension for the Perseverance Mars rover is a straightforward mechanism that consists of 2 primary components and other subcomponents. The front and rear wheels each have their own steering motor to allow the Perseverance rover to turn and swerve in any direction. Having 4 steering motors also gives this Martian vehicle the opportunity to turn a full 360 degrees while in place. The legs provide stability to the rover so that it can roll over any obstacle or through any divots that are up to the rover's wheel diameter and size, allowing for a safe and smooth journey for wherever it may be headed next.
Here is the body design of our Mars rover. Its main feature is to give structure to the build and to carry and protect all of the other equipment attached. It is used as an outer layer capable of keeping the internal electronics dry and warm. Finally, it is used to store and protect any collected rocks. The primary component built onto the body is the link and differential bar that connects to the suspension. It allows the wheels and suspension to be rotated around a horizontal axis, letting the rover transport over any obstacle in its path. The differential bar rotates about a hip joint, only stopping when in contact of the stopper box. And that is the body.
This is the power system on the Perseverance rover. This power system uses decaying plutonium as fuel to produce electricity to power the rover. The official name of this power source is the Multi-Mission Radioisotope Thermoelectric Generator, or MMRTG for short. The MMRTG converts the heat from the decaying plutonium into electricity, with some of the heat also being used to heat components of the rover, keeping them at their optimal temperature. Inside is the general-purpose heat source module, containing about 4.8 kilograms of plutonium dioxide. This is protected by layers of strong metals designed to withstand entering the Earth's atmosphere. In all, the system powers the rover, producing 110 watts at launch and heats all of the rover's components.
The mast of the Mars Perseverance rover is an important part of its design. It comes equipped with a number of tools, including wind sensors, cameras, microphone, and the SuperCam, which allows a laser system to understand, analyze, and transmit information about inorganic material back to Earth. With this component, scientists can get a 360-degree panoramic view of the surface of Mars. Overall, this is one of the most important components on the Mars rover.
The rover's collection arm allows for the analysis and collection of dirt samples. The following geological tools can be manipulated by the arm and are moved with the help of multiple joints. The drill cuts into the surface of Mars and collects rock samples. The drill has a coring bit that cuts samples from the interior of rocks and a regolith bit that cuts loose rock from the surface of the planet. Sherlock and Watson study materials in search of signs of watery environments. Sherlock captures the initial images of mineral samples, and then the Watson camera is used to magnify and record textures from those samples. Additionally, the Watson camera can be used to survey rover systems outside the view of the main camera. Pixel is also used to analyze mineral samples, but it is able to detect signs of past life. It does so by looking for changes in texture and chemical composition caused by an ancient microbial presence.